I am Raghavan, chemistry faculty from all four colleges. I welcome you all for the all four chemistry e-learning classes session 20. Now, see, in the last session, that is session 22nd, so we have done uncertainty principle, Heisenberg's uncertainty principle, that is the equation concept we understood. Once again, let us take the quick review about the uncertainty principle, that is Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. Uncertainty principle. Yes, Heisenberg's uncertainty principle. The principle itself says that it is uncertain. So it is uncertain principle. Okay, what is the statement of this uncertainty principle? It is impossible to determine simultaneously and accurately the change in position and change in velocity of the electron revolving around the nucleus in three-dimensional space. That is Heisenberg's uncertainty principle. Okay, so now in this, delta x represents uncertainty in the position into m delta v greater than or equal to h by 4 pi. This is uncertainty principle, mathematically represented like this. Okay, or we can also represent like this: delta x into delta p greater than or equal to h by 4 pi. That is where m is equals to mass of the particle and delta v is uncertainty in the velocity. Okay, that is change in velocity, rather we can say uncertainty in the velocity, and delta p represents uncertainty, that is change in momentum. Okay, like this we understood, and we also finally we concluded that is the verification of this Heisenberg's principle, like delta x is equals to h by 4 pi m delta v if uncertainty in the velocity is determined to be as 0, delta v is determined as 0, then uncertainty, that is the change in position is becomes uncertain, means undefined. Okay, that is one. So in the last class only we explained that. Just now we are taking only for the sake of revision of that concept once again. Okay, now delta v is equals to h by 4 pi m delta x when change in position of the electron is determined as 0, then the uncertain, the change in velocity is becomes infinity. Okay, the two things we completed in the last class itself, that is case 2, this is case 2 and this is case 1. That is uncertainty, that is when delta v is determined as 0, then uncertainty position becomes undefined. Then delta x is determined as 0, then uncertainty in the velocity is becomes infinity. Okay, this point we explained in the last class. Now, what are the points we can calculate by using this Heisenberg's uncertainty principle? We can calculate uncertainty in the position, we can calculate mass of the particle, we can calculate uncertainty in the velocity, we can calculate delta p, that is change in momentum. Okay, these are the points, and the important point, one more important point, remember Heisenberg's uncertainty principle is contradictory to the Bohr's atomic model. Very important, like you can find the question like this: Heisenberg's uncertainty principle is contradictory to the following. Number 1, de Broglie theory. Number 2, Sommerfield's atomic model. Number 3, Rutherford's atomic model. Number 4, Bohr's atomic model. Answer will be Bohr's atomic model. Like that you can expect the questions. Okay, right. Now let us go for the numericals based on Heisenberg's uncertainty principle. Okay, right. Numericals on Heisenberg's uncertainty principle. Yes, the principle is, that is the numerical on this Heisenberg's uncertainty principle. Yes. Yeah. The numerical is uncertainty in the position of a particle of 25 grams. Uncertainty in the position of a particle of mass is 25 grams. The mass of the particle is given 25 grams. Okay, we should be very careful with this. Okay, 25 grams in space is, that is uncertainty in the position of a particle of mass 25 grams in space is 10 to the power minus 5. That means delta x is saying that 10 to the power minus 5 meters. He said in meters. Hence, uncertainty in velocity is, uncertainty in the velocity, delta v we have to calculate. Uncertainty in the velocity is, and what about h? H, Planck's constant value, is given 6.625 into 10 to the power minus 34 joule second. Okay. Now the required formula for this is delta V is equals to H by 4 pi m delta x. Okay. This is the formula we required. Now be careful here. It is in SI unit. Okay, it is in SI unit. Consider, and pi value we know that it is pi is equals to 3.14 or 22 by 4, 22 by 7. Okay, and mass of the particle is given in grams. So rest of all there in the SI units. So that is 25 grams we should consider in kg. Okay, how to consider that? Mass is equals to 25 grams. Then that means 1000 grams is equals to 1 kg. Then 25 grams is equals to how many kgs? 25, okay, into 1 by 1000, okay, that is 10 to the power 3. Therefore, it is equals to 25 into 10 to the power minus 3 kg, right? So that is, the grams is converted into kg, right? Now substitute all the values in the given formula. Delta V is equals to H, Planck's constant, 6.625 into 10 to the power minus 34 joule seconds by 4 into 3.14 into mass of the particle 25 grams, that is in kgs. 25 into 10 to the power minus 3 kg. Okay. Into delta x. Delta x is how much? 10 to the power minus 5. 10 to the power minus 5. It is given in meters only. Okay. It is given in kgs. It is in kgs. It is in kg. Right. Right. Done. Now on solving this, delta V is equals to, find out. On solving that, so the delta V we have to find out accurately, that is the given answer is 2.1 into 10 to the power minus 28. 2.1 into 10 to the power minus 28, that is delta V meters per second, because all the contents are collected in SI units only. So therefore the change in velocity is calculated like this. Once again the data analysis, once again the problem. Okay. Uncertainty in the position of a particle of mass 25 grams in space is, that is uncertainty in the position, is 10 to the power minus 5 meters. 10 to the power minus 5 meters. The mass of the particle is given as 25 grams. Okay. Then calculate uncertainty in the velocity of the particle. And we understood that Planck's constant value 6.625 into 10 to the power minus 34 joule seconds, and pi value we know that. Right. Now this is the formula for us. Now h Planck's constant and pi 3.14. Mass of the particle is 25 grams. It must be considered in kg. Okay, let us see. So mass of the particle is 25 grams. 1000 grams is equals to 1 kg. 25 grams is equals to how many kgs? Cross multiplication. 25 into 1 by 1000. So that is 1000 means 10 cube. Okay, when it goes up it becomes minus 3. So this is 25 into 10 to the power minus 3 kg. Okay, that is equals to, now here only we can say 25 into 10 to the power minus 3 kg. Yes. So now substitute in the formula. Okay. So Planck's constant 4 pi m and delta x. On solving that, so the given answer is 2.1 into 10 to the power minus 28 meters per second. Okay. So the calculation part little tricky and it is time taking. Okay. You should be very careful while calculating, simplifying the things. Okay. So this is uncertainty principle numerical. Okay. Let us work one more numerical on this. Okay. One more numerical. What is it? One more numerical. Let us say like this. Uncertainty in the position and velocity. Uncertainty in the position and velocity. Okay. Now I will take out this one. It is a good model. So it is not there in our textbook. It is from the reference book, and it is a previous JEE mains numerical. Okay. Right. I read once again the numerical. The uncertainty in the position and velocity of the particle. That means delta x and delta p. Uncertainty in the position and uncertainty in the velocity. Okay. Both the values are available. Uncertainty in the position and uncertainty in the velocity of a particle. 10 to the power minus 6 meters. 10 to the power minus 6 meters. And uncertainty in the velocity of the particle is 5.27 into 10 to the power 5.27 into 10 to the power minus 24 meters per second. Minus 24 meters per second. Okay, done. So this is uncertainty in the position and this is uncertainty in the velocity. That means both are given. So that means he may going to ask answer, that is mass of the particle, I think. Yes. Calculate mass of the particle. Yes, done. Calculate mass of the particle. Yes. Calculate mass of the particle. Yes. As expected. Right. Calculate mass of the particle. Now, let us solve this. The required formula for us, as we know that mass of the particle is equals to h by 4 pi delta x into delta v. Yes. Now substitute all the values in this. Planck's constant value 6, because it is there in the SI unit, and delta x is also in the SI unit. So that is why we should take all the values in SI unit only. That is important. Planck's constant 6.625 into 10 to the power minus 34 joule second by 4 into 3.14 into delta x is given 10 to the power minus 10 meters into, and delta v 5.27 into 10 to the power minus 24 meters per second. Okay. So now on simplifying this, mass of the particle is equals to, on simplifying this, the mass of the particle is equals to 0.0 0.09999. It goes like this. It is kg. Yes, that is the numerical based on Heisenberg's uncertainty principle. Okay, so once again, just I read the numerical. The uncertainty in the position and velocity of a particle are 10 to the power minus 10 meters and 5.27 into 10 to the power minus 24 meters per second respectively. Calculate the mass of the particle. Okay, and Planck's constant value is given, that is h is equals to 6.625 into 10 to the power minus 34. Right. Next, let us experience one more numerical. Okay, let us find one more numerical. Calculate the product of, okay, it's a different numerical. Very good. Calculate the product of uncertainties of displacement and velocity. Uncertainties of displacement and velocity of a moving electron having mass 9.1 into 10 to the power minus 28 grams. Okay, mass of the electron is given in grams. Okay, that's right. So what we have to find? Uncertainty in the position, and that is product of mass into velocity. That is mass of the electron is given, and we have to calculate the product of uncertainties of displacement of and velocity. That means delta x and m delta, that is delta v. Delta x and delta v. Okay, what is the formula? It becomes delta x into delta v is equals to h pi 4 pi m. That we have to consider. Yes. Yeah. Calculate the product of uncertainties. Product of uncertainties. Okay. Interesting problem. Once again, read it. Calculate the product of uncertainties of displacement and velocity. Displacement means change in position and velocity means change in velocity. The product of these two we have to calculate. Of a moving electron of mass 9.1 into 10 to the power minus 28 grams is given. Okay, h, Planck's constant value, is also given. Right. So now calculate the product of uncertainties in displacement and velocity of an electron of mass 9.1 into 10 to the power minus 28 grams. Okay, done. So h, given that h is equals to 6.63 into 10 to the power minus 34 joule seconds, it is given. That is a problem. Now we have to calculate. So the product of delta x into delta v is equals to h by 4 pi m. Yes, that is a formula for us. That is equals to h, Planck's constant, 6.63 into 10 to the power minus 34 joule seconds by 4 into 3.14 into, yes, mass of the electron given in grams. We should be very careful. So Planck's constant value is already given in SI unit. So therefore we should consider the mass of the electron in kg. Okay, in kg. So to this you add, it is in grams. Add 10 to the power minus 3, isn't it? Into 10 to the power minus 3. That becomes 9.1 into 10 to the power minus 31 kg. Yes, done. Okay, then on solving this, on simplifying this, the answer is 5.77 into 10 to the power minus 5. 5.77 into 10 to the power minus 5 into 10 to the power minus 5. Yes, it is that is answer. Meter square per seconds. Meter square per second. Yes, this is the product of delta x into delta v. That is your answer. Okay, it's a good problem. Okay, visually, so we used to calculate either delta x or delta v. So now in this, the product is asking. The product of these two, that is equals to like this. The data is available and substituted, and on solving this is the answer. Okay, concept is very interesting concept, and it is. Once again, let us see the numerical. Calculate the product of uncertainties in displacement and velocity. Displacement and velocity. Okay, of an electron of mass this much. Okay, and Planck's constant value is available. Okay, based on the given data, we calculated the product of uncertainties, that is delta x and delta v. Done. It's very good. Right. This is the numerical based on this. Okay. One more numerical. Let us go with one more numerical. Right. I read the numerical. Listen properly. The mass of an electron is 9.11 into 10 to the power minus 31 kg. Calculate uncertainty in its velocity. Mass is given. He is asking us to calculate uncertainty in its velocity. If the uncertainty in its position is 10 picometers, and Planck's constant value is available. Okay, 10 picometers is given. Okay, that picometers, we have to convert that picometers into meters. Right. The next numerical, the problem says that uncertainty in the velocity. Yes. The next problem is, once again, let me read the problem once again. That is, the mass of an electron is given, that is in kgs it is available, and calculate uncertainty in the velocity, that means delta v is asking us to calculate. Okay, delta v find out. Then if the uncertainty in position is given as 10 picometers, be careful with this. The data available, delta x, uncertainty in the position is given as 10 picometers. You should be very careful with this. Okay, next, delta v is to be calculated, that is to be calculated. Then mass of the electron is given 9.11 into 10 to the power minus 31 kg. Yes, Planck's constant value is understood in SI unit, that is 6.625 into 10 to the power minus 34 joule seconds. Okay, done. Yeah, now delta v is equals to h by 4 pi m delta x. Yes, done. Now we should be very careful while transferring the data into this formula. Planck's constant value 6.625 into 10 to the power minus 34 joule seconds by 4 into 3.14, that is pi value 3.14 into mass of the particle. Yes, mass of the electron is given 9.11 into 10 to the power minus 31 kg. Yes, done. Then delta x is, now it is the important point, delta x is given 10 picometers. Very good, 10 picometers. Okay, so 1 picometer is equals to how much? 1 picometer is equals to, as we know that 1 picometer is equals to 10 to the power minus 10 centimeters or 10 to the power minus 12 meters. We should remember this value. 1 picometer is equals to, so therefore delta x is equals to 10 into 10 to the power minus 12 meters. Okay, it should be very careful in this. Okay, so therefore this is equals to 10 into 10 to the power minus 12 meters. Done. Okay, that we have taken here in this. Okay, it is clear now. Right, now on solving this, delta V is calculated as, on solving this. Okay, once again, in this problem, uncertainty in the position of the electron is given, that is 10 picometers is available, it is given. Then he is asking us to calculate uncertainty in the velocity, mass of the electron is given, and Planck's constant value is also available. Okay, so substituting the contents in the formula. So Planck's constant value by 4 pi mass of the electron into, this is the point important for us now, that is delta x is equals to 10 picometers, and we know that 1 picometer is equals to 10 to the power minus 10 centimeters, or it is equal to 10 to the power minus 12 meters. Okay, that means 10 into 10 to the power minus 12, or instead of this, so in place of this you can write 10 to the power minus 11. Okay, in place of this, it is nothing but 10 to the power minus 11. Okay, fine. On solving this, you will find the final answer is that is 5.76 into 10 to the power 6. 5.76 into 10 to the power 6 meters per second. That is, change in velocity is calculated like this. Okay, this is the numerical based on Heisenberg's uncertainty principle. Okay, then